To introduce the topic, let us consider a very common situation you must have come across in your life. Arpita went to a fun park in her town. She wanted to enjoy rides on the roller coaster and play shoot the balloon. The number of times she played shoot the balloon is 1/3 of the number of rides she had on the roller coaster. If each ride costs ₹4, and a game of shoot the balloon costs ₹3, and she spent ₹60 in total, what is the number of rides she had and how many times she played shoot the balloon? You might be thinking of considering several cases by trial and error. Did she take one ride? Is it possible that she took 2 rides? So on, and so forth. Or, perhaps you would think of using the knowledge from your previous grade to illustrate such situations as linear equations in 2 variables, x and y, depicting the number of rides Arpita took on roller coaster, and the number of games she played of shoot the balloon, respectively. Hence, mathematically, we can represent the above case in 2 equations. First, y is equal to x by 3. And second, 4 times x plus 3 times y equal to 60. Now, can we find the solutions for this pair of linear equations? Yes, we can. There are various methods of getting to the answer, which we will precisely cover in this chapter. As you know from previous grade, following are some of the examples of linear equations in 2 variables. 4x plus 5y is equal to 9. X minus 4y minus 7 equal to 0. And even x equals 3 can be rewritten as a linear equation in 2 variables as x plus 0y equals 3. Also, it is known to you that an equation which can be put in the form ax plus by plus c equals 0, where a, b and c are real numbers, such that a and b are not both 0, is called a linear equation in 2 variables x and y. It is important to note that the condition a and b are not both 0 is commonly represented by a squared plus b squared not equal to 0. You also know that a solution of such an equation is a pair of values, one for x, and the other for y, that makes the LHS of the equation equals to the RHS of the equation. For example, when we substitute x equals 1 and y equals 1 in the left-hand side of the equation for x plus 5y is equal to 9, we get a value 4 times 1 plus 5 times 1 equal to 9, which is equal to the right-hand side of the equation. Hence, x equal to 1 and y equal to 1 is a solution to the equation for x plus 5y equals 9. If on the contrary, x is 2 and y is 3, LHS of the equations becomes 23 whereas RHS is 9, so x equals 2 and y equals 3 is not a solution to the same equation. Geometrically speaking, 1, 1 lies on the straight line for x plus 5y equals 9 on the xy graph, whereas 2, 3 doesn't. This means that every point that is a solution to the linear equation will lie on the line representing the equation. This concept can be generalized for any linear equation as, whenever x, y is a solution of a linear equation in 2 variables, represented by ax plus by plus c equal to 0, the solution always lies on the line that is plotted for the equation. Also, the converse of this statement is true. Any point x, y lying on the line representing the linear equation, ax plus by plus c equal to 0, is a solution to that equation. Please pause the video, rewind and play again to absorb what has been covered in the topic. Let us proceed now.